everybody. In this video, we are going to discuss the law of cosines. We are going to find missing angles and sides in triangles, and we're also going to solve out the entire triangle. So we'll find every single missing side, and we'll find every single missing angle in the triangle as well. And you just see we have some representations here of some law of cosines formula. So let's see how to use it. So again, what's the point? So if you watch the law of sines video, law of sines and law of cosines kind of cover your bases as far as, hey, I have some missing sides or missing angles in my triangle, and it's not a right triangle, right? Because if it's a right triangle, SOHCAHTOA will take care of you, the opposite over hypotenuse and all of that. But in a non-right triangle, this isn't applicable. So we need something else. And law of sines is great, but that only takes care of the SSA case as well as the AAS case, angle side case. So what if we only knew all the sides or side and angle between them and the other side? Well, law of sines wouldn't help us here, but law of cosines does. And then this will kind of take care of every single case that you may have. And so therefore, now equipped with the law of cosines as well as the law of sines, you can find any missing side or angle in your triangle. So let's look at the law of cosines. So there's three different representations here because it depends on what you have. So any one of these are valid. And the way that I remember it is, okay, it's side and then the other side. So this portion here kind of looks like a Pythagorean theorem. So it'll be like, okay, it's pick a side and then it's other side squared plus other side squared minus, and then notice these two terms are the same as here. So minus the same two sides that appear here, and then cosine of the angle opposite of the side that you have on the other side of the equal sign. Okay, write this out enough and you'll kind of see that pattern that I'm talking about. Now, which equation do you need to use? Again, depends on what information you're given and what information you're trying to find. So we'll see examples of using each one of these here. So what I want to do now is I want to solve out this triangle completely, and this is the information that I know. And so based off of the information that we know, we'll kind of be able to figure out, okay, which of these formulas are we going to be using? So A equals 50, so that's this side, little a. Little b is 70. Okay, and big C, which is right here, is 60 for this whole angle here. Now remember, all triangles are kind of look like this. Little a and big A are across. All letters are across from each other. Okay, that's like the standard triangle. So what do I have? Well, I have a side, the angle between it and the side. So I have SAS, which means law of cosines will help me solve out the rest of this. Now what I'm going to use is I'm going to use the variation of the formula that has little c squared, because what I'm going to do here is I'm going to solve for little c. That'll give me all of my sides, and then I'll use some law of sines action to find a missing angle, and then I'll just use the law of triangles, 180 degrees for all the angles to find the missing angle. So that's kind of the strategy here. So let's find a little c here first. So I'm going to use the representation of law of cosines of c squared equals other sides squared, like Pythagorean theorem, minus 2 of these guys, a, b, times cosine of the thing I'm trying to find, but the big letter, cosine of c. Okay, so again, that's how I remember it. All right, let's fill in what we know. So we have c squared equals a squared, so 50 squared, plus b squared plus 70 squared, minus 2 times 50 times 70 times cosine of big C, which is 60. If we plug all of that mess into our calculator at the same time, we get c squared is equal to 50 squared plus 70 squared minus 2 times 50 times 70 times cosine of 60. We get 3,900. Then we square root that. So square root both sides, right, to get what c is. So we then get that c is equal to 62.4, but it looks like we're rounding everything to whole numbers here, so that's what I'm going to do. So 62.4 will round down to 62. So we're going to say little c here is equal now to 62. So great. Law of cosines helped me find the missing side. So now I have all sides and one angle. I could use law of cosines again to find the missing angle, or I could use law of sines. So let's do some review and kind of bring back some law of sines here. Let me find this angle A. So opposite side over missing angle, over sine of missing angle, equals, and I want to use the C pair because I know the information about both of them, equals side over sine of angle, which is 60. Okay? And now what this would be the SSA case, right? Side angle case. And so usually this is an ambiguous case, right? Remember, we can have 0, 1, or 2 triangles. But because we already know, and this is given that, hey, this is a triangle and this triangle exists, we know the 0 case is not true. Also, we know, like, hey, we've been given all the sides. So because all the sides are now stuck, all the angles are stuck too. So there is exactly one triangle with these particular dimensions. So we don't necessarily need to go through and be like, oh, how many triangles are there? Because we do know every side. So every side is stuck and there's no mystery about the third side like there was when we were doing the SSA case. So this guy we can just kind of solve straight through. So through some algebra, I know that sine of A is going to be cross multiply 50 times sine of 60. And then I would have divided both sides out by 62. So we get this. And then we're going to hit both sides with inverse sine. Hit both sides with inverse sine to get the sines out. So we get that A is equal to inverse sine of this guy. So A is equal to inverse sine of 50 times sine of 60 over 62. And that gives us 44.29, but again, we're doing everything in whole numbers. So we're going to drop that down to 44. So now that gives us that big A is 44. I just need to solve for B now, and for that I'm just going to do 180 minus 60 minus 44 because all angles in a triangle have to add to 180, which forces big B to be 76. Okay? So now we have used law of cosines as well as law of sines to solve out for every single angle and every single side in our triangle. We know absolutely everything now about our triangle. Let's do another example. So now solve this triangle. And what are we given here? We're given little a, 48. We're given little b, that's 75. We're given little c, that's 63. Okay, so we're given all of our sides. So remember, law of cosines also work for side, or SSS case, which is what we had. Law of sines isn't going to work here because all of our angles are missing. So we'll have to solve for 2 variables there, and that's not going to work. But law of cosines will do us. And actually, in this case, any representation of the law of cosines is going to work. So I'm going to use the one that starts with a squared. So I'm going to use a squared equals b squared plus c squared minus 2 times b times c times cosine of big A, right? These two a's match, big A and little a, and then it's b squared plus c squared. So I remember this again like Pythagorean theorem. And then minus 2 of these guys, cosine of the angle opposite of that guy. So this is a representation of law of cosines that I'm going to use. So let's plug in our pieces. A squared, 48 squared equals b squared, 75 squared, plus c squared, 63 squared, minus 2 times b, which is 75, times c, which is 63, times cosine of a. So we'll find big A in all of this. So through some algebra, I'm going to subtract, divide by this piece, and then hit it all with an inverse cosine. So let's see what that looks like. So 48 squared, subtract 75 squared, subtract 63 squared. All of this is going to get divided by negative 2 times 75 times 63. So that was just basically all the algebra steps at once. Again, subtract this, divide by this piece. That gives us cosine A. And then we're going to hit both sides with an inverse cosine. Hit both sides of this by inverse cosine. I'm doing it this way because we can just shove it all into our calculator. So let's take inverse cosine of this big mess over here. Remember your parentheses. Put parentheses around the numerator and denominator. So let's do inverse cosine of 48 squared minus 75 squared minus 63 squared, close parentheses in the numerator, divided by, open parentheses for denominator, negative 2 times 75 times 63, close parentheses around the denominator, close parentheses around the cosine, and we get 39.5. Let's see, we're using two significant digits, so that's going to round up to 40. So we got big A now is equal to 40. Great. Now again, we have SSA case, or we have SAS case. So we can either hit this with the law of cosines again, or we can hit it with the law of sines. It's totally up to you at this point. You have enough information to use either formulas. But I'm going to just use law of sines for funsies. So side, 48, sine of angle across of it. So little a, sine of a equals, and let's go for big C because I know little c. I could have also gone for the b's. It doesn't matter. So side over sine of the angle across it, sine of c. And again, this is the SSA case, but we do know that this triangle exists because it's kind of implied that it exists, and all of our sides are already set. So we will have exactly one triangle that will make this true. In this particular case, again, because the sides are fixed. So we would have sine of A is equal to cross multiply 48 sine of C and then divide out by 63. Hit both sides with inverse sine. So everything gets an inverse sine. Oh, excuse me. Sine of A is not sine of A. Pardon me. I was just writing out and not thinking. That's not sine of A, right? That's, because we know A, that's sine of 40. Ha. Okay, now cross multiplying, we would get 63 times sine of 40. These guys cross multiply. We're going to divide by 48 now because we're not solving for sine of A. We're solving for sine of C. Now we would hit both sides with inverse sine. Hit both sides with inverse sine. And C then shall be inverse sine of 63. So inverse sine of 63 times sine of 40. Oh, also make sure your calculator is on degrees, otherwise this isn't going to work. Divided by 48. We get 57.5, but we're rounding again, so this will go to 58. And that's big C, so big C now we know is 58. And then 180 minus 40 minus 58 gives us 82. Which means that angle there is 82 because all angles of a triangle again have to add to 180. So again, we use law of cosines, but this time we started out just knowing all the sides. So we had to solve for cosine of any of the angles opposite. And again, for side, 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 you can use any representation for the cosine formula and it'll all work for you. So we did that. We solved for one of the missing angles. And then we used law of sines to solve for one of the other missing angles. And then we said, okay, well, 180 minus 40 minus 58 equals 82. So this other missing angle must be 82. And then we got all angles of the triangle as well as all sides. So this is great if you're given numbers explicitly, but let's go see what this looks like in the form of a word problem. And let's do a bearing problem, because if we didn't have bearing, it wouldn't be quite as much fun. So 2 ships leave the harbor at the same time. Okay, I'm just going to write in some stuff for pictures. So that's the harbor, okay? The first ship is traveling at 14 miles per hour on a course of bearing south, 13 degrees west. So never eat soggy waffles. So southwest is this direction here, 13 degrees. Okay, so that ship's traveling there, and that ship is traveling at 14 miles per hour. Okay, got it. And this angle here between the black dotted line and the yellow line is 13. Okay, what about the other ship? The other ship is traveling at 12 miles per hour on a course with bearing northeast, right? Never eat soggy waffles, so northeast is over here. And that's on a 75 degrees. So the 75 degrees is off of the north line in the east direction. So that's actually kind of like this. And this angle right here, that is 75 degrees. How far apart are they after 3 hours? Okay, so what are we trying to find? We're trying to find, so after 3 hours, that ship is there, that ship is there. So how far apart are they would be the distance between them. Oh, look, I have a triangle. Perfect. Now what I need to figure out though, so how far is my red vector here? How long is it? Well, the red vector traveled for 12 miles per hour and it traveled for 3 hours. So this length is going to be 36 miles. My yellow vector traveled for 14 miles per hour after 3 hours. So 14 times 3. So this vector here has a magnitude of 42. All right. So I know two sides. If I could get the angle between them, I could use some law of cosines and I could find my missing side. So let's look at this trickery here. So 75 is this angle here. 13 is this angle here. The question is, if I could figure out this angle here between the black dotted and the red, I could add that with 13 and that would give me this entire angle in total. Well, in fact, I can. It's 180 minus 75. Now, how did I know that? Because the black line is a straight line. What's the degree of a straight line? It's 180. So 75 in this angle here would be supplements. In other words, 75 in that angle need to add to 180. So if I subtract 75 from 180, I will get this angle here, which just gives us 105. So I actually now know that the angle between the black dotted and the red is 105. So I now know that that's 105. So this angle here is 105. That angle there is 13, which means I can get this whole angle here by adding them together. And when I add 13 and 105, I get 118, which means this angle here is 118. And now I have, and let me erase all these parts that I don't need anymore. Don't need that. I don't need my black line anymore. Kind of just clearing out all the stuff that I was using earlier. And now I just have a perfect triangle. I have a side, I have an angle, I have a side. Let's use some law of cosines. Let's do it in white. So what am I missing? I'm just going to call that side little c. So if I'm missing a side, if you want to find the missing side, I'm going to have that, I'm going to use the representation of law of cosines for the missing side at the left sign of the equal sign. And you'll see why, because I have all the information for everything else to fill in on the right side. So c squared is equal to a squared plus b squared. A squared plus b squared, it really doesn't matter who's a, who's b. Minus 2 times a times b times cosine of the angle across, which we have. It's 118. Okay? That's why, again, I chose this representation to make my missing side the squared variable on the left side, because I knew at the end of the equation we were going to have to take cosine of the angle across, which we knew. This is why side, angle, side works so well for law of cosines. So we will have then that c is equal to the square root of all of this, right? Because we're going to square root both sides to get c. And all of this we can just slam into our calculator. 36, 42, cosine of 118. So let's see what C equals. It looks like we're using two significant digits, so we're going to round to the nearest whole number. And so square root of 36 squared plus 42 squared minus 2 times 36 times 42 times cosine of 118, close parentheses, very important. We get 66.9, but we're rounding to nearest whole number because I'm looking at my other significant digits in my problem. So I'm going to round this out to 67, and the units are miles. So solving this problem out, we have figured out that the two ships are 67 miles apart after 3 hours. And we got this just by using law of cosines. We figured out the bearing stuff. We found our missing angle between these. We used a little bit of angle trickery and kind of everything else we knew about angles and supplements and straight lines. And ultimately found our distance between. So I hope you guys enjoyed this video. I hope you guys learned about how to use law of cosines. Again, if you have all sides of a triangle, law of cosines will help you find the angles inside of the triangle. Also, if you know side, the angle between it and the other side, law of cosines will help you find that third missing side. And then you'll have all sides, and you can use law of cosines again to find the other missing angles, or you can use law of sines at that point. Basically now, since you know law of sines and you know law of cosines, you are equipped to solve out any triangle anywhere. Right triangles included, use SOHCAHTOA. Non-right triangles, use law of cosines, use law of sines, and you guys will be set to go. And then again, as always, if you have any questions, please don't hesitate to ask.